Welcome back. In a previous video, when I did a restoration of one of these modules, LP1171, I did say I had another one as a spare. Well, this is my spare one, so I thought what we'd do is have a quick look inside this and see how it differs to the other one I did. So bear with me, I'll just pull it apart. The reason for the delay is I just wanted to get my phone so I could take another photo of this, and hopefully if I can work out how to do it, I'll post the pictures side by side so you can have a look at the differences. But I have had this one apart before actually, so I do know what the differences are. So let's whip the bottom cover off, and the little bit of card that goes in there. See if we can get you in a bit closer. There we go, hopefully you can see that. Let's make sure you can. Yeah, that looks okay. So let's pop this one out. There we are. So hopefully you can see that, not too much shine on the light. So, if you remember in the last module I took apart, we had 3 AF116s. In this one we've got an AF115, an AF116 and an AF115. I believe they run this way across the board. So I think the first IF is down here. But, yeah, unusual. What I was going to quickly do was I'm going to have a look, just going to touch the case and see if we've got any shorts initially. So let's have a quick look and see what we got here. So I'm going to clip this on the case. No. Right, okay. How did I manage this last time, eh? Right, oh. There, that's the ground. Let's have a little probe about then. See if that is the ground first. Yeah, that's dead short. So we've got a lead over here. Yeah, we've got a slight reading on that one. And another lead there. 5k on that one. This is in circuit, but it shouldn't really affect it. So that's the collector. So 0.24k. 0.2k on that one. Where's the other one gone? Over here. 6k. Let's just pop it onto the kilo-ohm scale. Ohms. So I've got no blatant shorts there. I'm only getting a reading on the kilo-ohm scale, which is still pretty bad. You know, it might be not a dead short yet, but these things keep on growing, and it will be. Yeah, the worst one is the shield to emitter. So it's got shield to emitter fault. It's only, again, it's about 1k, give or take. It's changing now. So that's that one. That's the AF1115. So let's just trace that back a minute. Saying that all the earths are connected really, so let's see if we can find out which is the earth pin. One of these is the earthy pin. What would have been the earth pin there? Yeah, that's the earth pin. So let's have a look at the transistor. So that is, this one's in the other way around. So we've definitely got quite a short there on the emitter to earth. Best way to test these is to get them out, so that's what I'm going to do next. So bear with me. Okay, see, I've done another of my little photos for this to help me determine which ones are which. So here they are, all out of circuit. So let's have a test and see what they're doing. Let's say we've got one AF116 and two AF115s. I also had to take these out of the way as well. Basically they were stopping me getting the last transistor out. They were right in the way and I couldn't actually see the legs to make sure I knew which one was which. So anyway, this will be my master copy now. I've only done this roughly for a minute, but I will print this off properly. So if anybody wants it, you're welcome to send me an email or a link, and I'll fire it across to you if you want it. As I say, this is the LP1171. So it certainly makes it a lot easier if you know which ones to desolder from the back, and then they just literally drop out from the front. Okay, well, let's continue. So now you should be able to see my bench meter. I'm going to need to get some multiple cam setups, I think. This is crazy. So, first transistor then, this is an AF115. Let's make sure the leads aren't touching. So I'm connected to the shield now. Let's that into auto ranging. Again, really we shouldn't get any readings here, but let's have a look. So let's do collector first. Nothing there, that's a good sign. Base. Nothing either. Emitter. Nothing. Well, there you are. That's a good AF115. Let's double check that again. That's just me touching it. Let's try that again. Oh, hang on. Bit better connection now. That appears to be fine. Let's just touch a card to make sure. Yeah, that was good. So I'll do this now, just let it do a little arrow right there. Yeah, 115 good. 116. Try the 116. Again, let's hook up onto the shield wire. So let's go emitter first. There we are, we've got a short there, 92 ohms, that's definitely way over. Base. So it's difficult to actually clamp these leads in, they're so fine. So I've also got a short on the baselet, not a great short, but it's pretty high resistance, but it is still measuring. Collector. Yeah, we're getting a reading there as well. Strange, I'm not getting a reading there, I'm not. It's probably these croc clips, they're not brilliant. Let's try again, that's a bit better. There we go. 79 ohms, shield to emitter. Eleven mega ohms, shield to base. 11 mega ohms, shield to collector, so that one's no good. It's the AF116. Last one, another AF115. So let's make sure I've got decent connection straight off this time. There you go, right, first to emitter. Oof, yeah, sent me some ohms again. Get a good connection on these leads, that is. That was a good clip directly onto the can, couldn't I really? Let me just see if I can get a better connection on that one. Just clip it straight to the can. Oh, try this. This might be a bit better. So can to shield, dead short. That's my printer kicking into action now. Calibrating it says. Okay, so the case to the emitter. Nothing on that one. Base. Collector. Yeah, so strange. There's nothing on that one. Just double checking myself there. Oop. What do you know? Both AF115s are checking out okay. Not that I won't zap them, mind you, but it's only AF116 that's bad. There we are. But they're all going to get zapped, because if there ain't whiskers shorting quite yet, they soon will be. Never worth the risk. Okay. Okay, stuck with me. So, there we have it. Two good AF115s and a bad AF116. So, once again, we get the trusty AF127s out. Three. I suppose I really ought to make sure these are okay, didn't I, before I go swapping them in. Make sure we got slightly older one now. Just hook one of these up a minute and just test it with my meter. Bear with me. Okay, I've drawn out the pin outs of these as well, just to remind myself, and useful if you need it. Saves you looking it up. So these are looking at the underside of the transistor, by the way. So I've hooked up some better leads this time. Hoping these are going to go better. So let's hook up the shield first. So I'm looking at my multimeter, so I can't get you in both of it at the same time. No reading between shield and collector. No reading between shield and emitter. And no reading between shield and base. Shield and case. Should be a short, yes. What I will also do to each of these as I put them in, so I'm going to pop them on my component tester. Just make sure there's nothing amiss. It tells me it's a germanium HFE 236. All these germaniums have got a pretty good HFE, so we know that one's good. Let's do another one while we're here. Just want to remember which one's which, because I'll forget in a minute. Cool, 553 HFE on them. I don't know how important this is, whether you ought to really match them, I don't know, but let's see what this one is. 165. That's a bit random, isn't it? This is a bit of an older one. Pins are a bit dodgy on this one. Well, not dodgy, they just need cleaning up really. 137 HP. So it's quite close to that one. .207, so that's quite close to the other one. And the last one. .149. So that's over with that pile. .81. He's a little bit out on his own, that one. Shows how different these transistors are. That's one of the things with germanium, that's they're not really as... Oh, hello. What have we got there? No component detected. Did I have my lead clicked on? Are they dirty? Have I been given a duff? AF127. Try again. That is possibly a duff transistor. Try again. Could just be dirty leads on it, but I'm struggling. No, don't like that one. Anyway, I'm not going to bore you doing this forever. Join me again in a minute. Okay, I picked out 3 transistors which are going to go in. They're all from the same batch, round about the same HFE. Don't need to worry too much about that, to be honest. But strangely, when I was testing them, these 3, bear in mind I've got probably about 20 of these. These 3 here, don't know how to get these mixed up. For some reason my component tester just couldn't detect them at all, so they're going to be in my pile for further investigation. So just as a comparison, I was measuring the HFE on the AF127s. I know there's no component detector, so I haven't fitted it yet. So what I'm going to do is just hook up one of the AF115s which checked out for no shorts, just to see what the comparable HFE is on this. .145, so pretty similar to the ones I'm going to fit really. They're all around 150, 160. Again, I don't think it makes a major difference in this particular circuit. Let's try this dud AF116, see what it says about that. 180 HFE. Let's connect the shield in line. It thinks it's a diode now. It thinks it's an LED. to read a short. I just want to see if it would read a short, that was all. So there isn't really a dead short there, but no. It likes that, even though we know there's some of the old tin whiskers in that one. Let's try my other AF115, so ignore the shield, just go collector, base and emitter. Give that one a go. 164. So pretty much what I'm going to be popping in is pretty similar. That's really what I was trying to achieve, just to see for my own knowledge really. So there we are. That's my 3 I'm going to pop in. So I should put those in and join me when I've got them all back in circuit. So as you can see, I've excuse me, finished off soldering the 4 transistors in. As we can see, if I hold it that way, you can see the little bits sticking up, or I've not clipped them off yet. So I've got a little bit waylaid on this, my soldering iron, but not let those fly all over the room. Just whip them off. I say I've got quite a few of the Roberts R600s, and I have definitely marked at least one of them with module not working, so this will save me a bit of time. It's nice to have a hopefully working one. I won't know until I put it in a radio really, but there's no reason for it not to work, I don't think. So the board's lifted a little bit just here, I don't know if you can see it. You've got to get a fair bit of heat on that end bit. Bend the clip up. Let's get my magnifier in there a minute, just have a quick look. Don't want to snap that bit off because I'm going to solder it back on. Let's just move that over. It's only barely hanging on there. I don't know what they fixed these to the boards with, but there wasn't very good. It doesn't really like to be soldered. No, it's not going to go. Oh well, as I say, that doesn't really perform any function apart from keeping that lug in. Other side's fine. So let's just give that a clean off very quickly. Smoothing roll. So get the old flux cleaner on it. Newly fixed iron on. You can see with the state of the end of the brush here that that's pretty mucky. That's not all my doing either. It's been mucky from when it was fluxed up originally. With my isopropyl, nice and clean. Just let that dry off. So the top of the board, where are we? There you go. Let's get some of this stuff back out of the way. Let's put you in a little bit closer so there you can see the transistors that I put in. Again, the AF127s I put in there. 3 of them there. They're all bang on. I've checked that the legs aren't shortened together. I don't know what they paint the front of that with, but so yeah, there we are, all done. All I've got to do now, I mean, I suppose I could change the electrolytics while I was in there, couldn't I? But they look okay. What have we got there? We have got 10, 16 volts, 2.5, another 10, that's another 2.5. I have got some 10s, some nice new ones there. But I haven't got any 2.5s. What I might do is just whip one out a minute and see what it measures. If it's okay, I shall put it back in and leave the rest. Okay, hopefully you can see the ESR meter there. I'm just going to hook this up. So this is a 10 microfarad, 16 volts. Just pop that on. Reading 15.5, so that probably is out of tolerance. What's that? Probably 20%. Yeah, 2.4 ohms. Let's just try a new one. Microfarads, 2.2 ohms. It might just be that I've heated that one up. As it cools down, it might No, I'm not convinced. 15 is a bit far out, so joy. Looks like I'm going to need to swap these out then. So let's have a look. That's positive. Positive was down there. Negative bent over. Let's get that one out of the way. That doesn't hold up much hope, does it? That means probably be a little bit out. Whereas if I change it, it might throw it out anyway. But anyway, I like to have it just right. So let's pop that back in. Just going to solder that one back in a minute. Put a bit of flux on because I don't know, it just seems to give you a much nicer joint with the flux. Plus these leads aren't particularly clean. There is resin in the solder wire, but magnifying. Okay, these are capacitors I've taken out of the module, and just as what I did actually. These ones here, they're not. They would work okay. They're reading high. I mean, there should be 10 microfarads. Most of them are 15, 16 microfarads. It's not a massive amount out really, but I got one here in my tester. Again, another 10 microfarad. There is a 2.5 microfarad in there, but that one's not too bad actually, but I've changed it anyway just because it's the same age as the module, which is going to be probably late 60s, early 70s. So this is the only one that was really a problem. Let's turn my ESR meter on here, hopefully you can see that. There we go. Let's push the button. So ESR on that is 23.4 alerts, so that one is absolutely shot. So just as well I've changed it. Anyway, join me again in a minute, I've put it back together. There we go, all recapped. Well, any of the aluminium electrolytics have been replaced. As I say, they're mostly 10 microfarads. There's only one that's different, that's a 2.5 microfarad. I haven't got that, so I put a 3.3 in there, which is not much difference, so that'll be fine. So yeah, all done. I've just finished cleaning the board off, and I've also cleaned these pins up as well with the solder sucker. So I've just got basically now solder it back into the can. So let's put the soldering arm back on. Again, with these, just make sure that your holes are lined up. And obviously don't want you to touch it, that's why they've stuck the label over there, covering up some of the holes, but no touchy. So is it that way around or that way around? It is. Yeah. So that going again. Just bending this back in. Remember this too much. Just solder that back on. Tiny bit of flux because there's a little bit dirty connections on that. There we are. One repaired module. What I'll do now is just make sure that little hole there lines up. There must be a test point in the middle there, because that little hole lines up with this little tiny bit in there. So obviously that was something that Mullard tested when they brought them back. The other thing I'll do is just straighten these pins up a bit. I have sapped the excess solder off of them. A couple of these pins are a bit short really. So I'm hoping they'll go through the case. Looks like it would just go through the board. If not, I'll have to come apart and I'll have to solder new wires in, so hopefully all is good. So I hope you enjoyed watching that, and join me for another video soon. So there's already written something on here before that's out of an R600 UT. I'm just going to put in there that I've put AF127 and the date is 3rd 16. There we go. All complete. Thanks for watching.